right, good morning, everyone. Thank you for joining. How's everybody doing this morning? Doing well. Glad to have you here. We've got a great session lined up for you today. We've got Tim, oh no, I promised I wouldn't butcher it. Lukowskowitz? Great. I tried hard on that one. Tim Lukowskowitz from Cerner Corporation. He'll be discussing how they deployed AppDynamics and user monitoring data. So with that, I will hand it over to Tim, and we'll get started.
Great, thank you. All right, so I'm Tim Lukowskowitz. I'm a technology architect at Cerner in the CTS Corp Ops division. So kind of first and foremost, we're just going to run through kind of some background, the challenge that we were tasked with solving. We're going to go through some really dry, boring technical implementation steps that are there just so they're in the slide deck later for when you get back to work. And then we're going to go through our use case with how we used the UEM data to drive a remedy acceleration project and kind of the values and returns that we got back out of that. And then kind of a more generic how that data can be used to drive that acceleration initiative. And then just kind of talk through some of the results of what we got out of it. So first and foremost, Cerner, I don't know if any of you have heard of us before, but we're a global healthcare IT company. We have 200 offices around the world. We're in something like 8,000 facilities, upwards of 2 million hospital beds. We have had rapid growth year over year for years on end now. And one of the important things is our primary data center presence is all in Kansas City. So on the CSM or Corp Ops team, we have about 50 engineers of varying roles and levels. We're organized into 4 lanes built around the business units that each of the lanes support. We are responsible for all of the enterprise applications at Cerner, and so kind of our mantra is, if you use it to do your job at Cerner, we manage it. We are responsible for 24/7 support, which is why we have a third of the team out in India. They take over for us each night. So the challenge, pretty simple, speed. Every user wants their applications to be faster. Faster applications enable users to be more productive, and it really makes them happier with us as the operations team for the system. So within the last 2 or 3 years, since we bought out Siemens Health, we have grown tremendously around the world to where we had 27 offices in 2013-ish. We now have over 200, and they're scattered in more than 40 countries across the world. So as I said, our primary data center presence is in Kansas City, so that's where all of our business services live, is at our world headquarters, and that can present multiple challenges. So as part of this acceleration project, we realized that we had smaller, kind of tertiary data center presences in these locations around the world, and we started to look at how could we leverage those to improve our user experience for all of our enterprise apps. So, the big challenge is the applications wouldn't work for users outside of Kansas City. People that were in Europe were reporting, 30, 60-second page loads. The page would never load. And when we would go to look at the system after we get the user complaints, everything looks fine. CPU on the database, app servers, everything looked great. Like I said, we had that rapid growth of Cerners outside the US that drove a lot of these where, it used to be kind of a one-off thing. We could give them a VDI and it would work around their problems. Now we have almost, a third of the company that's based outside of Kansas City, and it really started to impact the productivities of the rest of the business units. And that kind of, cascaded down into providing a poor experience for our clients as well. So why does it matter? Why does speed matter? So one of the statistics we pulled up was that every 100 milliseconds delay in a page load on Amazon costs them 1% of their total sales. 75% of people are willing to wait 5 seconds or less. We've all hit that slow web page. It takes too long to load, takes too long to buffer. We just cancel out. We'll go do something else. We'll come back later. Hopefully it'll be better then. One of the interesting things is that psychologically, they did a study and they said, whatever your average load time is, if you ask, it feels 15% slower than that to a client or a user that's using it, and then when they tell somebody else about it, the next day or later on, they'll say it was even 35% slower than that was. So at this point, you have a 50% kind of degraded performance just from the human perception of how your application is performing. So we, in Corp Ops, we do a lot of reactive monitoring. So, you can see our suite of tools. We have one of the big things at Cerners. We have 5 tools to do everything. So we have very comprehensive reactive monitoring, capturing CPU and disk metrics and all that stuff. But one of the problems we run into is by the time that we get to a point where, CPU spiked or whatever, we're already impacting our users, as well as, the reactive monitoring, it doesn't always give us the big picture of what's going on. Everything may seem fine, but that doesn't mean that we're providing a good user experience to the users trying to use the application to do their jobs. So enter real user monitoring or end user experience monitoring, depending on who you listen to. But the idea is that rather than doing either synthetic workloads where we try to guess at what a user normally does in the application or guess at their workflow, we capture the metrics directly from the real users using their application to do their daily job. So this way we don't miss any edge use cases. We're able to gather metrics from around the world wherever the users are. And I'm going to talk a little bit about how we implemented that and how it works. But the idea is that we get a true sense of what the users are feeling and how the application is performing in real day-to-day tasks in production. So this is where we're going to step into kind of how we started to do this. I know the official line from AppDynamics is that usually to implement UEM, you deploy an Apache proxy with mod rewrite, and you start rewriting the HTML to inject the scripts to make it work. For us, we are already leveraging our F5 load balancers as the proxies between the users and the application servers. We don't want to add another layer of proxy tier, another thing to break, another thing to slow down the application by having to make extra hops. So we started to look at how could we do this with the F5 itself. So we didn't need any additional infrastructure. So what we ended up using is what's called an HTML rewrite profile. It is new in the 11.4 code base, I believe, for F5 TMOS. And what it does is it just looks for the close of the head tag at the top of each web page, and it injects a single line of JavaScript in front of that line. And what that line does is it pulls back the ADRUM.js file, which is what makes up the core of UEM, and it allows basically JavaScript to capture the timings for the rest of the objects during the page load. One of the challenges that this helps us meet in deploying UEM is we no longer need developer assistance to deploy UEM. We don't have to log a point to them to try and get the monitoring scripts injected. There's no development time, and it really simplified the rollout and development of this data by allowing ops to basically single-handedly take this and deploy it across the world as we needed. So there's kind of 2 phases to running UEM. First off is injecting the script into the page so it actually triggers and starts to gathering the metrics. And the second part is actually delivering the ADRUM.js file that contains the meat and potatoes of what UEM actually is. So like I said, I'll click through these real fast, but basically, so the first time you use an F5 to do this, you have to go and build this rewrite profile. You do that by building a prepend HTML rule, which is what we did. We have some kind of general naming conventions. We have some applications where putting the ADRUM.js file at the root of the URL structure didn't work, so we had to kind of build one-off ones. And so we just append the name of the application that the rule's for at the end. Next, you copy and paste the JavaScript that the AppDynamics UI gives you from the controller just into the prepend rule. Set your match settings to wherever you want it to appear in the page, and then just make sure that src equals line matches wherever you had to put the file. Next, you're just going to create a profile from that rule, which is just a wrapper around it in case you want multiple rewrite rules on the same website, or VIP rather. And then we put it in common so that we can use that same rule across all the applications. That way we know that prod and cert and dev are all behaving the same. And then we move into, for every time. All right, now that that's set up, we just navigate through local traffic to the virtual server menu. We select the virtual server for the application we want to instrument, and then we attach that HTML profile that we built in the last step to it. One of the things that I tell my engineers is make sure that when you go to make that change, make sure that box is empty and it's set to none right now. You can only have one HTML profile applied per virtual server, so if you're already using that functionality for something else, you want to make sure that you don't break whatever that other thing is when you turn this on. You hit update, you save, sync the change across the pair, and you are done. You are now rewriting the HTML live for every page request that goes through. And then we kind of move into the second one. So one of the challenges we ran into, even with that part, was, well, for some applications, there is no static content store. There's nowhere we can drop this JavaScript file and make it accessible to users directly. So we found a way to do it with a little more magic. So we have two basic models. So there's the hosted model, which is the simple one, where you drop the JavaScript file out on the website in whatever folder it's serving from. So for Apache, it would be var www HTML. For IIS, in the inet pub, just so that when users request that and basically their browser is triggered to pull that file down by the UEM script, that they can get to it. For examples when that doesn't work, we use an iRule on the F5 that basically all it does is it looks at the URI of the HTTP request. So if that URI is the JavaScript file, then we rewrite the URI to a different file name, and then I change the pool dynamically off to another server that is just a static content store for all these JavaScript files. Some of the challenges, you need firewall ACLs from the backside of this F5 that's running your prod application to wherever the AppDynamics. So we ran this on our AppDynamics data collector as an additional service. You don't necessarily have to do that. You could put it on any web server and still serve the content. Or you could actually also have the F5 serve the file directly by embedding all of that content into the iRule. For us, we have about 170 different applications, so that was a lot of overhead to manage to try and load all of that onto the F5 to respond directly. So next we're going to move into kind of how we got into this, how we figured out that we needed this, and kind of describe some of our challenges with it. So Remedy is kind of the core, if you aren't familiar with it, kind of the core of all of Cerner's IT operations. It's used for ticketing, for change management, for incident response. We have 2,100 daily concurrent users. We have 10,000 active users that are in there. We create about 5,000 incident records every day. And before we started this project, it took about 135 seconds to create an incident record. That was on average, so it could be slower if you're further away in the world. It could be faster if you're in Kansas City. But basically it boils down to about 185 hours a day are spent doing nothing but clicking through the workflow, waiting for Remedy to load, and entering all these incident records. So we get a lot of complaints that look like this. Remedy is slow. Well, that's not any better than our basic up and down automated monitoring, right? So that doesn't tell me where they are, what they're trying to do. Are they running a report that's pulling back every ticket their team's had open since the 1980s? Or is this just, creating a new ticket, something that should be quick? Are they at home on their, 3G connection from their basement? Are they in one of our corporate offices? And we really struggled with basically taking these complaints as they would filter through to us in, tier 3 operations and turning that into something actionable, that we could investigate, that we could work to resolve. And so what AppDynamics UEM gives us is a unified global performance analysis. So we can look at this geo dashboard that's in UEM, and I can see from around the world at a glance where is our usage coming from at that point in time, as well as what's the application performance look like. So you can see kind of the circles there. The size of the circle indicates the amount of usage. The color of the circle indicates the performance of that location against its own baseline. So UEM dynamically generates baselines for each location by observing your application's real-world performance. So rather than having to set hard thresholds of, if it's slower than 4 seconds or slower than 7 seconds, we can say, hey, if this is slower tomorrow than it was today, automatically trigger us an alert and we need to go look at what's going on. Is there a network event between that office and our corporate data center? Is there something going on with the application server and these users are just the ones that happen to get routed to that server first? And it enables us to have real numerical hard data to both investigate troubles, as well as when somebody comes to us and says, hey, I was in this office yesterday and Remedy wasn't working. We have the data that says, no, it was just fine. We have thousands of hits that came from that office at the same time, and everything was working great. We're within our performance baselines, and we can, down to a user ID or IP address level, track every click through the application. So we started to do some performance testing with an upgrade that we did this year. We'll kind of jump through this because we'll revisit it later. But if you look at the colors of the lines indicates a percentage of our production workload. So this is in our certification environment. So with AM off, our average page load time is about 10 seconds up to 75% of the production workload. When we hit 100%, basically page load times go off the charts. 60, 70 seconds for page load time, and that was the experience that we were told, was kind of all the time in prod from our users in India. So we looked at how could we make this faster? What are the different options that we could use in order to improve that user experience? One of the first things we looked at was using a using a CDN, which is the quick and easy solution, so to speak. And when we looked at that, we could see that from BMC and CD Network's own white paper that they published about how they improved memory performance, what they showed, which was they brought page load times down to 18 seconds. We were already faster than that, except for that edge use case when we were basically overloading the system. So thanks to the UEM data, we didn't have to look at using one of these CDNs because we were already faster than that all the way around the world. So before we move into kind of how we use the UEM data to drive the F5 acceleration, I'm just going to do a quick overview through kind of just the concepts of HTTP performance and the different factors that can kind of impact that. First, so we have the life of a single HTTP request. So the first thing that happens is you have to resolve DNS, from the host name back to the IP address. The browser makes a connection to the server or to the F5 in our case. It makes the request of what object or content that it needs, and then it waits to receive it from the server. For each website or each web page that you load, this process can happen, up to 30, 40, 50 times. For Remedy, we found out for the initial page load into the overview console was 76 separate requests. So we had to go through the same lifecycle over and over and over. And when we start looking at our round trip time from our BLR office to Kansas City, it's nearly 300 milliseconds. So for each of these phases, you have to make that round trip all the way to the data center and back. So if you look at that, even with the concurrency, you can do up to 6 requests at once. That's still a lot of time waiting for back and forth between the user and the server. So this creates kind of this waterfall effect where you can do some requests, a couple requests at a time, but then the rest of them have to wait. And basically, the user's experience isn't until you get all the way to the bottom right and the page is completely loaded and rendered. TCP is designed to be slow to start, so it kind of probes the network to figure out the available bandwidth. And lots of HTTP connections are very small and bursty, so they really don't fit well together for HTTP. One of the other things that we looked at is that lost my place. Is that the network round trip, right? So Google released this study where basically they showed that once you hit broadband speeds of internet or about 5 megabits per second, increasing bandwidth doesn't really help your page load times at all. You get some nominal improvement, but the round trip time is where it's really at. So we have users that are like, well, why don't you just upgrade the internet connection to our office? Like, well, it doesn't really make a difference. So while improving bandwidth is easy, you can always turn up more fiber, more connections, increase the bandwidth. Decreasing the latency between 2 locations is really hard. Basically, what the study said, it was about $80 million per millisecond to decrease the latency between 2 physical locations across the world. Because you have to run new pipes from one end to the other. You're bounded by the speed of light, so data traveling through a fiber optic cable, and we really can't get any faster than that. So the solution to all of these challenges is we use the F5 Application Accelerator or AAM module. Basically, it's a collection of technologies that allow us to optimize the entire delivery chain of that HTTP request. So first off, we look at the DNS lookup. So using the F5 GTM or DNS product that comes in the same license with AAM, we can do DNS caching, or we can create an authoritative DNS responder on site with the user so that they don't have to come all the way back to the data center for that. We optimize the server connection. So can we bring the server closer to the user so they aren't having to make that whole long round trip? Can we improve the performance of the SSL? So when you make that initial connection, you have to make 1 round trip for the TCP 3-way handshake to finish. When you put SSL on that, you're now making 3 round trips before the browser has even requested the object and the server started churning to generate it and send it back. Can we optimize the request? Can we make the server respond faster or need less data in order to deliver that object back to the user? And then is there any content optimizations? Can we compress the data? Can we minify it? Is there any way to cut down on the amount of packets that have to go back and forth between one side and the other? And so we look at, we layer these optimizations together. So there is no silver bullet for the performance optimizations. By using lots of these technologies and combining them together, that's where we really are able to start making the difference. So first off, very simple, load balancing. That's something that I imagine everyone with a major IT presence is already doing. Just you increase the number of servers, the users don't realize they're hitting different ones, and by doing that one, you offload processing away from each individual server, which makes it individually respond faster, as well as increasing your capacity overall. Second, we want to offload stuff away from those servers so they're doing less work and can get new connections in and get them back out faster. So one of the things that the F5s are fantastic at is accelerating SSL, because they do it in a dedicated circuit on board, so an FPGA. So rather than taking lots of CPU cycles to run through the encryption code, it just does it in a snap, because it has dedicated circuitry, just like an ASIC in a switch, in order to encrypt and decrypt the data. The F5 we found is also a lot better at managing large numbers of TCP connections efficiently. So by decreasing the number of connections between the F5 and the server, using a one connect profile, we decrease the connection tracking scoreboard within the web server, and that allows it to be more efficient with the way that it both manages connections as well as responds to requests, because it doesn't have to try and figure out which user it needs to send the object back to. Next thing we want to do is we want to use a fast cache. So this is where kind of that CDN model comes in. So repetitive traffic, like there's no reason for my application infrastructure to be churning on all the images and CSS files that are the same across every request. Let it focus on actually applying the business logic to the data and transforming it into a way that's useful to the user. And we're letting the F5 basically offload all of the images and CSS documents and serve them from a RAM cache directly to the user. And finally, we have basically a protocol gateway. So the F5 has allowed us to deploy speedy and HTTP2 much faster than our vendors have supported it, because basically what it does is it allows the user's browser to talk HTTP2 to the F5. The F5 then translates that back into 1.1 streams and talks 1.1 with the server, so it doesn't realize that the user is using a new protocol. Some of the performance benefits you'll get out of HTTP 2.0, even just in the gateway mode, is that you can increase the number of concurrent streams from the default of 6 to as high as you want to go. We have our profile set right now to allow up to 25 streams per connection, which is basically per user. And basically, really the only major thing that we're missing out with 2.0 with the gateway mode is we don't have server push yet. So that's one of the performance improvements, is the server can start to push objects to the clients before they even request them, if it knows that it's going to need them for the rest of that page load. So now that we've kind of talked through, kind of the different technologies, how we apply it, I'm just going to run through, what difference does this really make to our user base? So this is that same diagram that I showed you earlier with the load times. So when we turn AAM on, or I'm sorry, we're going to zoom in a little bit so you can see down at the bottom here. So really about the same, between 50 and 75%, depending on which step of the workflow you're going through, up to about 8 seconds. So when we turn AAM on, this is what our performance numbers look like. And if you notice at the bottom there, I'm not sure if it's easy to read, but we are now able to scale up to 200% of our production workload in our CERT environment and still have faster page load times than we started off with no load against the systems in the beginning. Kind of zooming in, show that we now have every step is 6 seconds or less. Performance is great. The servers are happier. The database is happier, because we've basically offloaded all of that traffic away onto the F5 instead. I was told by the lawyers I was not allowed to talk dollars, but I can say that basically what we're looking at in terms of impact to the business is about 18 full-time employees worth of time saved each and every day creating incidents alone. And this technology can be applied across all of your applications that are on your F5 with no additional cost. So while we just turned this on for Remedy right now, we have 6 other of our Tier 1 enterprise applications that are targeted to be completed by the end of this year, and we're looking to do the other 140 of them by the end of next year to basically bring them into the same level of technology. And so finally, the way forward. So what are we looking at? We are now geolocating accelerators all around the world using GTM to route users to the nearest one. And this both kind of gives us a twofold benefit. First off, I can steer traffic around offices that are experiencing an issue. So if the fiber gets cut in Bangalore and people aren't able to get there, using GTM, I can have the F5s automatically route those users to the next closest office. to pull back that content from, or if they need local resources like LDAP or something out of AD, all of that is enabled through there, as well as the performance improvement. So for Remedy, we could offload about 80% of the objects required to load a page into the cache. So now, rather than having to come back to Kansas City for all that data, the user is able to request it from a device that's there, sitting in a network office or a network closet in their office, rather than having to take the long trip back to Kansas City. Kind of move into questions afterwards, but thank you for your time. If you want to send in a survey, they've asked that we display this. And if you have any questions afterwards, I'll have my email address up here in a minute. Feel free to contact me. If you are unsure who to get in contact with F5, I can get you in touch with people there that know about how AAM and my config will be available online on Dev Central if anybody wants to use our acceleration profile for Remedy. I guess, does anybody have any questions? Sure. Oh, I think Danielle's got the mic.
When you used F5 for injecting the end user monitoring, were you able to do any user data injection as well, or just the out-of-the-box injection?
We are not doing it today. That is something that we're starting to look at. So like you said, so basically like capturing like the user ID and other metadata about their like browser and environment. So we're not doing that yet. It shouldn't be any reason, right? So if you can build a little JavaScript to gather that data and include it into the metrics, it should still work.
Hi, and you mentioned about you have close to 100 applications. How do you configure that ADRUM.js for each app, because it's specific to the app name and the key? So how do you manage them?
So for most of the applications, we try to just put it on the web servers with the rest of the application, right? So that way it's specific to that application. For the ones where we have to use the central hosting one, we rename the file to basically the host name of the website. So www.cerner.com would be that adrum.js file name. And then using the F5, we rewrite that back to adrum.js before it's delivered to the user.
Okay. Another thing is the mention about the F5 optimization, right? Is it kind of a replacement to the Akamai cache, CDN, where, serving from the closest to the data centers?
It's similar. We actually have looked at using both technologies. So using F5 to optimize the content before it's delivered, which will save us, bytes of data through Akamai, and then using Akamai to kind of deliver to the very edge, basically places we don't have a data center presence. So East Asia and stuff where, Australia doesn't really serve that effectively. We're hoping that we can use Akamai to kind of extend the reach without, incurring the rest of the cost of using that for the entire application traffic.
Okay. One last question. I'm going back to the ADRUM and F5. I'm rewriting, right? Are we missing anything in the what AppDynamics is capturing, like a DNS resolution or first byte to respond, all those stuff?
Nope. We capture all of the same data points that you do when you use the other methods.
Okay. Thank you.
Another question over here.
Just from a security standpoint, I was curious with all the TLS and SSL vulnerabilities, if you've had a good experience with F5 quickly updating the FPGA-based acceleration, or have you run into any problems there where it's been slower to update?
No, so they run their own TCP stack. They're not built around OpenSSL or anything like that. So they've actually found that they have already mitigated a lot of the vulnerabilities that have come out, and the ones that they haven't, that have been protocol level attacks, they're usually at or ahead and have always issued fixes for us within a week or two. Faster than the application owners want to move with making those changes anyways.
Any other questions? We've got another one.
I forget exactly what you said. If you hosted the ADRUM on the controller or on F5 itself?
So we are hosting the ones that we can't deliver to the application on the UEM data collector, so that's a separate server from the controller.
Okay.
So that's kind of been the dumping ground for that for now. There is no reason we couldn't do it directly from the F5. And so in actuality, with AAM, that's one of the objects that gets cached into the page. So for the most part, it is getting delivered directly from the cache on the F5. But basically, we put it on that web server just because when we were trying to spin this up really fast, that was a convenient place. We already had a server up, and it was related to the rest of the application. So, it's simple and easy.
Okay. I think we're looking at implementing the same topology. So that's an edge server, and
Yes.
then you've got ACL rules coming back to your collector.
Yep.
So after it digests those beacons and pushes the data in.
Yep.
Perfect. Thanks.
All right, one more over here. A lot of questions.
Can you talk a little bit about what it was like before we implemented this? I'm JT, and me and Tim worked together to implement this. What it was like collecting these metrics and understanding what was happening beforehand and then after, and then sort of how rapid it was to actually get to where we were.
Sure. So before we had AppDynamics and UEM available, we kind of went through 2 or 3 phases of, okay, we have hundreds of complaints. Obviously, not all of them are bogus. There are problems going on. So we first started with just one user sitting at a desk running HTTP watch from the office, manually capturing timings with Excel, running through, averaging them together, and that was basically our performance baseline. Not real great. It was terrible data. It didn't match anything that anybody was telling us, and it was only from one location. So the next phase we moved into is with a major upgrade that we recently did to 9.1 of Remedy. We started doing load tests. So both at actually slamming the system with thousands of requests level to where, in our certification environment, as well as we basically spun up a load test running in Scappa that basically it was just a single simulated user that would just hit prod, every 5-10 minutes and see what kind of performance data it got. But we're still limited that we could only capture the data from the location where we had the load test infrastructure, right? And in both of these methods, right, there's, especially with the load testing, there's weeks of effort that have to go into, building all of these scripts to test and trying to capture the most realistic workflow for our users that we could. And once we got UEM data, it was about 10 minutes, and I had a complete snapshot of every piece of, every user's experience from around the world. And it just made such a tremendous difference for the way that we were able to respond to these complaints, as well as one thing is we have a help desk unit that's always creating these tickets 24/7. Every time that we had an issue, they called us first and they told us about it. When you have the best monitoring system available, which is a team of 40 or 50 human beings clicking through the application that can instantly log a ticket to your team about performance problems. With the AppD data, we are now actually ahead of them even in the application, where we can start to see the average response time for the application climb, and we can get on and start investigating before they come to us. And that's been a huge differentiator in terms of MTTR, resolving these incidents, and has made that organization's leadership very happy that they feel like we're on top of stuff, we're working on it, and that we care about it, and we're not just sitting there waiting for them to call us and say that there's an issue.
Any other questions? Oh, one more.
Hi, Tim. Thanks for sharing your data with us.
Sure.
2 questions. First is, from a project standpoint, how many users was part of your test group to around the world there to get the data that you need to claim it as a success? How many Remedy users were?
You mean
impact.
like for what we were capturing with AppDy or before
Yeah,
that?
Before that, yeah.
We capture it from every single user. So every click that everyone does in Remedy, we capture every data point about them, and we log it so that we can analyze it.
Okay. And how long did you get to start the project till end of project? Was that 60 days, 90 days?
It was, about 2 months, and 90% of that was our own server provisioning processes. So once we actually got the server ready and installed the data collector to it, it was about 3 days before we're up and running at a production level.
Okay.
And that's we also manage it on-prem. So I know there's a SaaS option that AppDynamics provides, but we manage all of our own internally.
Okay. Thank you.
Great. Anyone else? I think
Great.
that's good.
Thank you very much.